right, you guys, I'm going to kind of do this over. I had the wrong number written. I knew I did that too. So we're going to start off with this problem. And we're going to start off with each solid has an unusual property, that the value of its surface area is equal to the value of its own, or of its volume. So this is a 6. I wrote the wrong number in here, so I'm trying to fix that. But it's not very easy to see. So the first thing you're going to do is you're going to write the equations. So we know that the surface area, to find the surface area, it's 2 times the length times the width plus 2 times the length times the height plus 2 times the height times the width. If we didn't remember that, we could always look that up on the internet. And so what we would do is we would assign the length would be 6, the width would be, that's a 6, it's hard to see, so 6, and the height is going to be our x because that's our unknown. And we're going to substitute these in, so it's going to be 2 times 6 times 6, let's see if I can get a 6 there, plus 2 times 6 times x, plus 2 times x times 6, because the width is 6. And then that's going to equal the volume, which is 6 times 6 times x. I'm sorry, that's not necessarily working very well here. There we go, and 6. And then what we would do is the math. So 2 times 6 times 6 is 12 times 6 is 72, plus 2 times 6 plus x is 12x, so that stays 12x, plus 2 times 6 is 12, and that's 12x, equals, and then 6 times 6 is 36x. So let's just ignore this right here because that's where I had put the wrong number in. All right, sorry about that, guys. Now we're going to solve the equation for this, for x. So we have 12x plus 72 plus 12x equals 36x. That's what we got from up here. So the first thing we want to do, since we have a variable on both sides, we want to move the variables to one side of the equal sign, and we want to move the constant terms to the other side. So if you want to, draw your line, and I have 2 x's over here, so I'm going to move, well actually since this is the only one here, I'm going to move these over. So first I'm going to combine them. So 12x and 12x are 24x plus 72 equals 36x. So now I'm going to subtract these 24x's here and subtract 24x's here, and that gives me 72. I can't write. 72 equals, and if we subtract, we get 12x. Now we would divide both sides by 12, and x equals 6. Okay. Now we're going to use the value of the x to find the surface area and the volume of each one. So what we would do is we'd go back up to our formula, and we could put that in to find it. So 2 times 6 times 6, which we said was 72, plus we had 2 times 6 times x. So now the x is 6, so it's 2 times 6 times 6, plus we had the other one that was 2 times x times 6. So we take the x out, so that'd be 2 times 6 times 6 equals, and then we had our volume. And our volume was 6 times 6 times x. So now that's 6 times 6 times 6. And we can find out that the volume, 6 times 6 times 6 is 216. That'd be inches cubed. And this one This would be 12, that's 72, plus 72, plus 72. And if we add those, 72 plus 72 plus 72 is 2 plus 2 plus 2 is 6. 7 plus 7, that's 14. And that's 21. So 216 inches squared. So the surface area is equal to 216 and the volume is equal to 216, which is exactly what we said at the beginning where we said that they were equal. Okay, so what did we learn? Solving equations with variables on both sides. We have to solve the equations with both sides by collecting the variable terms on one side and the constant terms on the other, and then solving for your variable. So let's look at a couple examples, and I'll try not to mess this one up. So we have our x's, so I'm going to move this one over here, and that way I have a constant by itself. So I would add 2x and add 2x. Those are gone. They cancel each other out, leaving me with 15 equals, if I have negative 7 and a positive 2, that leaves me with negative 5x. Divide both sides by negative 5, and that leaves me with x equals, because a negative divided by a negative is a positive, 15 divided by negative 5 is negative 3. So x would be negative 3. How do I check it? I can go back up here and put a negative 3 into my equation. 15 minus 2 times negative 3 should equal negative 7 times negative 3. So let's try this. If we multiply, negative 2 times negative 3 is 6, and 15 plus 6 is 21, and negative 7 times negative 3 is 21. They do equal, so that was my check. All right, let's try this one. Now on this one, I'm going to do my distributive property first on both sides. So do the housekeeping. So we get negative 2x plus, because a negative times a negative is a positive, 10 equals 12. 6 times a negative a half, so what's half of 6? 3, and it's a negative, so minus 3x. Now we want to move the variables on one side, and we want to move the constant terms. So since this is a negative, I'm going to add 2x to keep it positive. And those cancel, leaving me with 10 equals, and over here I get 12, and I'm going to end up with negative x, because we understand that if it's just 1, it's just an x. So minus x, or you could put a 1x if you want. Now we're going to move this over, so we're going to subtract 12. Those are gone, so I get negative x equals, and I would get a negative 2. I'm going to divide both sides by negative 1, and x equals 2. Okay, we could have also done the other. If we would have done this one and we would have added 3x, we would have had a positive and not had to deal with that negative at the end. But either way, it would work, whichever side. Okay, so right now I want you to go ahead and pause, and I want you to try these. Okay, this is what you should have had for your first answer. All right, now you could always go to the other side. I took this one over because I already had a constant by itself. On number 2, you should have had something that looked like this. And number 3, you should have had something that looked like that, z equals 3.